Hi guys. Welcome to today's notes on adding linear expressions. So, a linear expression is an algebraic expression in which the variable is raised to the first power and is not multiplied or divided by another variable. So right here are some examples of linear expressions: 5x, 3x plus 2, and x minus 7. Here are some nonlinear expressions: 5x squared, because it's raised to an exponent, that's not 1. 3x cubed minus 2, because it's raised to an exponent. And 4xy, because we're multiplying x and y. I circled y, they're not. You can add linear expressions with or without models. Sometimes you will need to use zero pairs, i.e. 1 plus -1 equals 0. These would cancel out. Or x plus -x would equal 0, like when we combine like terms. All right, here's example 1. 3x plus 4 plus 2x plus 1. There are two different methods. On the left, I'm using models. On the right, I'm just using the expressions and combining like terms, which you know how to do that. All right, so 3x plus 4, I draw 3 rectangles for x's, 3 small squares for 1's, 2 rectangles for x's, 1 small square for 1. They're the same color because they're positive. Now, I'd rearrange the tiles so I keep the same pieces together. So I put all my rectangles that represent x together, and I put all the little squares that represent my 1's together. 1, 2, 3, 4, 5, 5x, 1, 2, 3, 4, 5, 5, and I just count. Or we can use algebra, we used algebra tiles over there. And we just combine like terms. Or we can use method 2, stack them and add them. So, as long as it's an addition expression, we can stack them and add them. 3x plus 4 plus 2x plus 1. Positive 4 plus positive 1 is positive 5. Positive 3x plus positive 2x is 5x. And they're the same signs, add, and this should say add and keep sign. Different signs, subtract and keep sign of larger absolute value. All right, let's look at a different example. Example 2 is here. I know it's kind of harder to see because it's smaller. So let's just do... Okay. 3x plus 2 plus -x plus 4. Again, model method over here. Stack and add over here. We can draw out a model. 3x's plus 2, -x plus 4. Notice how this was a different color. You probably won't have colored pencils with you, but just make sure that you realize that this is a -x. Just as long as you distinguish what they are. Like you can draw like rectangles like this, right? On your paper if you want to. Group tiles with the same shape, then remove any zero pairs, okay? So x plus -x is equal to 0. So I'd get rid of these, and I'm left with 1, 2, 2x plus 1, 2, 3, 4, 5, 6. And that's how I get 2x plus 6 using the model method. Now, I could just stack them, okay? 3x plus 2, -x plus 4. Same signs, add and keep signs, so 2 plus 4 both are positive, so just add 6. 3x plus -1x, they're different signs, so subtract 3 minus 1 is 2. Since 3 is further away from 0, it's positive 2, so 2x plus 6 is my final answer. You can use whichever method you would prefer, as long as you show your work. Okay? Here's a third example. Write and simplify an expression to find the perimeter of the figure to the right, then find the perimeter of x equals 4. So, if I look at the figure here, to find the perimeter, add up the sides. So, x plus 5 plus 2x plus 2x minus 2. I didn't have enough room to write the minus 2 up here. So let's combine like terms. 2, 4, 5, 6x plus 5 plus negative 2 plus 5 minus 2 is just plus 3. 6x plus 3. This is the expression. That's step 1. This is our perimeter expression. Now, we know x equals 4, so substitute it in. 6 times 4 plus 3. 24 plus 3 is 27 units. The perimeter of the figure is 27 units. So I would need the expression and the perimeter to get full credit for this problem. All right. Here's my last worked example. And here's where it gets a little tricky. Notice that we have the lovely distributive property that's decided to show up. So we can add linear expressions with the distributive property. 2 times the quantity x plus 3 plus 3x minus 1. Remember, the distributive property means I have how many groups of x plus 3? 2. So that's how I represent it with models here. X plus 3, x plus 3. 2 groups. This is where the method model isn't going to be as efficient, because depending on what number is outside the parentheses. And then 3x plus 1. Rearrange the tiles to combine like terms. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I'm gonna circle the 0 pairs and finally remove them. So, okay. And then I count 1, 2, 3, 4, 5, x. 1, 2, 3, 4, 5, positive 5. Or method 2, which you're probably gonna end up using, is this. First we need to distribute. 2 times the quantity x plus 3 is 2 times x plus 2 times 3, which is 2x plus 6, plus 3x minus 1. That didn't have anything, it had a 1 in front of parentheses, so it doesn't change. Stack them and add them. 2x plus 6, 3x minus 1. Use your addition rules, same signs add and keep sign, different signs subtract and keep signs of larger absolute value. So positive 6 plus negative 1 is positive 5. Positive 6 plus negative 1, different signs subtract. 6 minus 1 is 5. Positive 6 is further away from 0, so it's positive. 2x plus 3x is 5x. And we still get 5x plus 5. All right. So these are problems that I'm going to have you try, but I specifically want to go over number 2 here because, look, we've got fractions we're dealing with. Okay, so we have to use our fraction rules here. So negative 3/2 x plus 1 7/10 plus 9 1/10 x minus 3/10. So this becomes plus 1 4/10. And the thing I forgot to do was make it so I need to change this to 5/10. So it's a common denominator. 5, so it's 3, 9 minus 3 is 6. So I have 6 1/10 minus 5/10 x. I need to switch back to the 6 1/10 minus 5/10 times x, which is 5 11/10 minus 5/10 x plus 1 2/5. I'm just reducing 4/10 to 2/5 here. What I did is I took 6 1/10 and there are 10/10 in 1, so by changing this to a 5, I can make this 10 plus 1 is 11. 11 minus 5 is 6, so I have 5 6/10 x plus 1 2/5, reduce to get 5 3/5 x plus 1 2/5. And that would be my answer. Okay, now let's try the first one. You can use models, or you can use, I'm going to use models, x, 1, x, and then little squares. And then if I put them together, I would get 3x plus 6 Either method's fine. Obviously, this one it's harder to do models with because it's rational coefficients. And yes, you'll need to be able to deal with rational coefficients. Okay? All right. This one we have to distribute first. We can do this 5x minus 20 plus 2x plus 7. I'm going to stack them. Negative 20, oh, sorry, you can't see. Negative 20 plus 7 is negative 13. Well, negative 20 plus 7 is 20 minus 7 is 13, but since this is further away from 0, it's negative. 5x plus 2x, they're same sign, so just add them and get 7x. So 7x minus 13. This one we have to distribute for both of them. Notice how I draw the arrows so I don't forget. 2 times x is 2x. 2 times negative 10 is negative 20. 3 times 2x is 6x. 3 times 7 is 21. Stack them. Use your integer rules. Negative 20 plus positive 21, subtract 21 minus 20 is 1. Since 21 is further away from 0, it's positive. 2x plus 6x, same signs add, so 8x plus 1. Okay. Now we're going to get into some more problems. This page is double-sided. There's 16 problems. Okay. So write an expression and solve for the perimeter of the figure below if x equals 0.8. So add 2 at a time. So I'm going to label these sides. 9x minus 4, 2x plus 3. And we're going to stack them. Negative 4 plus 3, so different signs subtract. 4 minus 3 is 1, but it's negative 1 because this is further away. Negative 4 is further away from 0. 9 plus 2 is 11x. And then we're going to just throw in the 9x minus 4. Same signs, add and keep sign. Negative 1 plus negative 4 is negative 5. 11 plus 9 is 20. So I get 20x minus 5 is my expression. Then we need to substitute in 0.8. 20 times 0.8 minus 5, which is 16 minus 5, which equals 11 centimeters. So the perimeter of the figure is 11 centimeters. Okay. All right, write an expression and solve for the perimeter of the figure below if x equals 0.8. Well, this is a rectangle, so I know these are the side lengths, but I'm going to set this up so I use the distributive property because I have 2 sides that are 5x plus 1 and 2 sides that are 4x minus 1. Distribute. Two times 5x is 10x. 2 times positive 1 is positive 2. 2 times 4 is 8x. 2 times negative 1 is negative 2. Stack them. 10x plus 2, 8x minus 2. 2 plus negative 2 is 0. 10x plus 8x is 18x. So I know my perimeter expression is 18x. Then we substitute in 0.8. Okay. And let's see, that's 40 plus 3272 divided by 5. Which is 14.4 inches. So the perimeter of the figure is 14.4 inches. Or you could say 14 2/5 inches. Okay? All right. Sorry, the pen I was using died. So, all right. Again, I'm just going to stack these. Negative 4x minus 1, 5x plus 3, negative 1 plus 3, different signs, subtract 3 minus 1 is 2, and positive 3 is further away from 0. Negative 4x plus 5x, different signs, subtract, 5 minus 4 is 1, and 5 is further away from 0, so my answer is just x plus 2 here. Okay, this one, we need to distribute. I'm going to draw the arrows to remind myself. 3 times x is 3x. 3 times 14 is 42. Negative 2x times x is negative 2x. Negative 2 times negative 7 is positive 14. Now I'm going to stack them. 3x plus 42, negative 2x plus 14. 42 plus 14 is 56. Same signs, add and keep sign. Same signs, add and keep sign. Wow, I can't talk today. 3x plus negative 2x. Different signs, subtract. 3 minus 2 is just 1, so just x. So x plus 56. So our answer here. Okay. The lengths of the side of golden rectangles are in the ratio of 1 to 1.62. So the length of a golden rectangle is approximately 1.62 times greater than its width. Write and simplify a linear expression for the perimeter of a golden rectangle. Then find the perimeter of the golden rectangle if the width is 8.3 centimeters. Round to the nearest hundredth if necessary. Draw a picture of a rectangle. Oh boy, there's a lot here. So we know that it's 1.6 times greater. The length is 1.6 times greater than the width. We need to write a linear expression for the perimeter, and we need to find the perimeter if the width is 8.3 centimeters and round to the nearest hundredth. So I'm going to start by drawing a picture. So I know the width is x, and we know the length is 1.62 times greater, so that's 1.6 times 1.62x. Now if I'm finding perimeter, and add up all the sides, so 2 times 1.62x plus 2 times x, because I know this side and this side have to be equal, and this side have to be equal if it's truly a rectangle. It's a poorly drawn rectangle, so that looks a little better. Anyway, so this is 2x, this is 3.24x, which is 5.24x. This is our perimeter expression. Now I need to substitute in 8.3 for the width. Remember, this is the width here, which just happens to be x, so we can just substitute it in for x here, okay? And we can plug that into our handy-dandy calculator and round to the nearest hundredth. Okay, 5.24 times 8.3, we get 43.492. We're going to just round this to 43.49. This will be centimeters. So the perimeter of the golden rectangle is 43.49 centimeters. Again, you would need the expression and the answer to the perimeter to get full credit for this problem. All right. A rectangle has side lengths 5x minus 1 and 2x plus 2. Write and simplify a linear expression for the perimeter of the rectangle. Find the perimeter of the rectangle. The value of x is 5 2/5 units. Hint, draw a picture of a rectangle. So again, start by drawing a rectangle. So we know it's 5x minus 1 and 2x plus 1. Again, because of properties of rectangle, this side and this side have to be equal, this side and this side have to be equal, so 2 times 5x minus 1 plus 2 times 2x plus 1. Why do I feel like we already did this problem? Maybe we did, I don't know. Anyway, distribute, we get 10x plus 2, 4x, oops, sorry, this should be minus. See, I just made a mistake. 10x minus 2, 4x plus 2. Stack them, 10x minus 2, 4x plus 2. negative 2 plus positive 2, subtract 2 minus 2 is 0. 10x plus 4x is 14x. So I know my perimeter expression is just 14x. And I know the value is 5 and 2/5. Okay. So 14 over 1 times 27 over 5. 378. Okay, so 20, 40, 60 plus 15 is 75 and 3/5 units. So the perimeter of the rectangle is 75 and 3/5 units. Remember, you'd need the perimeter expression and the answer to get full credit to the perimeter. Okay. All right, we got a few more problems to do, and then we're done. All right. Distribute. Okay. Negative 4 times 2x is negative 8x. Negative 4 times negative 5 is positive 20. 3 times 7 is 21x. 3 times 5 is 15. Stack them. So you get 20 plus 15 is 35. Negative 8 and positive 21. Different signs subtract. 21 minus 8 is 13. And 21 is further away from 0, so it's positive. So my answer is 13x plus 35. Okay, this one we can just stack. Different signs, so subtract 3 minus 1 is 2. Positive 3 is further away from 0. Negative 2 and positive 1, subtract. 2 minus 1 is 1, but negative 2 is further away, so it's negative. So my answer is negative x plus 2. All right, we got 4 questions left. 0.5x plus 15, 8.2x minus 16.6. Different signs subtract. So 16.6 minus 15 is 1.6, but this is further away from 0, so it's negative. Same signs add. So 0.5x plus 8.2x is 8.7x, so 8.7x minus 1.6 is our answer. Distribute. Don't use the model method here. It would be super inefficient. 10x minus 20 plus 6x plus 6. 10x minus 20, 6x plus 6. Negative 20 plus 6 is different signs subtract. 20 minus 16 is 14. Negative 20 is further away from 0, so it's negative 14. Same signs add. 10 plus 6 is 16x. But 16x minus 14 is our final answer there. Distribute. 4 times x is 4x. 4 times 2 is 8. Negative 3 times 2 is negative 6x. Negative 3 times negative 3 is positive 9. Now stack them. 4x plus 8. Negative 6x plus 9. 8 plus 9 is positive 17. 4x and negative 6x, different signs subtract. 6 minus 4 is 2. But since negative 6 is further away from 0, it happens to be negative 2. So this is negative 2x plus 17. All right. Distribute. Okay. Negative 2 times negative 2 is positive 4x. Negative 2 times negative 1 is positive 2. 3 times x is 3x. 3 times negative 4 is minus 12. Stack them. Different signs subtract. 12 minus 2 is 10, but negative 12 is further away from 0, so it's negative 10. 4x plus 3x, same signs add. 7x. So 7x minus 10. And that's it for our adding linear expression notes. Thank you for watching.